Good morning, students. Now I'm going to take a topic that is antenna, right? So antenna is important instrument in communication system, right? So without antenna we can't send the signals and receive the signals. Which signals? Electromagnetic signals, right? Okay, so antenna is very important one. And see the picture. See, this is one mobile tower. So this tower contains n number of what? Antennas and different size. This is concave shaped, yes, antenna. This is bar shaped, yes, antenna. That is helical shaped antenna. And this is the what? Concave shaped antenna. So these are the what? Types of antenna. Yes. Shall we go to the topic? Okay. Yes, so what is antenna? What is the exact definition? See the definition. An antenna is an electrical device which converts electric energy into radio waves and vice versa, right? And it is usually, yes, used with the radio transmitter or radio receiver. Okay, so both it is act as a transmitter and receiver. Yes, that's why we called a TR function. What is TR function? Transmitter and a receiver function. Okay, an antenna is a device used for sending or receiving EM waves. Which waves? Electromagnetic waves, right? And go to the the last one. An antenna consists of a transmitter and a receiver. That's why we called TR. Yes, transmitter and receiver. Okay, and what are the types of antenna? Yes, the types are majorly 5 types. The first one is Yagido antenna, helix antenna, parabolic antenna, loop antenna, horn antenna. So these are the types of antenna. The parabolic antenna and helix antennas are most worldwide using antennas. Okay. Next, see that again is types of antenna. This side, wire antennas, aperture antennas, reflector antennas, lens antennas. And for wire antennas, example dipole antenna, monopole antenna, helix antenna, loop antenna, right? And if you go to the aperture antennas, waveguide, that is opening antenna, and horn antenna, right? And reflector antennas, parabolic reflectors and corner reflectors, right? And if you go to the lens antennas, concave plane antenna, convex plane antenna, convex antenna, and concave lens antennas. These are the types of what? Antenna, right? Okay, parameters of antenna. Yes, it contains some parameter. The parameters are, yes, consists of bandwidth and gain. Now first see the first one, bandwidth. It specifies the range of frequencies over which its performance does not suffer due to a poor impedance match, right? This is the bandwidth. I'll tell you later what is exact meaning of bandwidth and what is the channel bandwidth range. Yes, okay, now go to the next one, gain. So gain is a parameter which measure the degree of directivity of antenna's radiation pattern, right? Okay, and the last one is effective area or aperture. The effective area or effective aperture of a receiving antenna expresses the portion of the power of passing EM waves. Which waves? Electromagnetic waves. So this is the parameters of what? Antennas. Okay, yes. See that simple definition. Antenna is a device which acts as an emitter of electromagnetic waves, and it also acts as the first receiver of energy. Yes, in that antenna some important characteristics, that is what? Attenuation. Attenuation is the loss of power of radiation due to the absorption of energy in space and the power density goes on decreasing as the electromagnetic waves go away from their source. Okay, and it is proportional to a square of distance traveled, and it is generally measured in decibel. So decibel is what? Yes, that is noise. Okay, this is about what? Antenna. Yes, see the types of antenna. Yes, see the types of dipole and helical. Yes, pyramidal. Yes, pyramidal horn antennas we called as horn antenna. So this is what horn antennas, right? And parabolic reflectors. This is one parabolic reflectors. Okay, and the dipole antennas are mostly using in high towers, and here also helical antennas also used in what in high buildings. Okay, and the next one is bandwidth, right? The bandwidth is nothing but, in electronic communication, bandwidth is the width of the range of frequencies that an electronic signal uses on given transmission medium. Right? In this usage, bandwidth is expressed in terms of difference between the highest frequency signal component and the which frequency lowest frequency signal. Yes, and no of bytes per second, that is digital signal, right? This is about what? Bandwidth. Is another definition for bandwidth. Bandwidth is the difference between the upper and lower frequencies in continuous band of frequencies. The pass band, yes, the bandwidth is the difference between the upper cutoff frequencies and lower cutoff frequencies. For example, a band pass filter, a communication channel, or signal spectrum. These are examples for what? Bandwidth, right? At the same time, yes, the bandwidth for amplitude modulation, 10 kilohertz to 5 megahertz, 10 kilohertz to 5 megahertz. Okay, at the same time, the range of frequencies required to transmit a piece of specified information in a particular channel is also called as channel bandwidth. It's also called as what? Channel bandwidth, right? Yes, again I'm telling you. So the range of frequencies required to transmit a piece of specified information in a particular channel is called as what? Channel bandwidth. Yes, it starts from 10 kilo hertz to 5 megahertz for AM transmission. That is what? Amplitude modulation signal transmissions. Okay, yes, and come to the antenna size. Yes, in our book this is the information is given. Antenna is used at both transmitter and receiver end. Antenna height is an important parameter to be discussed. The height of the antenna must be multiple of lambda by 2. What is lambda? Wavelength. Yes, what is wavelength of the signal? Yes, and see this given in your book. Lambda is equal to c by nu. C is the speed of light, nu is the frequency of the signal. Yes, transmitter signals, right? This is the size of antenna. So the size of antenna, yes, must be multiple of what? Lambda divided by 4. That is wavelength of the signal divided by 4. Yes, for example, yes, I think it is not visible. Anyway, I have to adjust. See the example. Let us consider two baseband signal. One signal is modulated and the other is not modulated, right? The frequency of the original baseband signal is taken as nu is equal to 10 kilohertz, while the modulated signal is nu is equal to 1 megahertz. Okay, see that the height of the antennas required to transmit the original baseband signal of frequency nu is equal to 10 kilohertz. Therefore, we have to find out the what height of the antenna, which is equal to lambda by 4, which is equal to what, c by nu, because of what, lambda is equal to, yes, which one, c by nu. That's why here c by nu. Therefore, speed of the light 3 into 10 power 8 and divide by 4 into 10 is into 10 power 3. This 10 power 3 is nothing but kilo. So therefore, yes, so here but 10 power 8, here 10 power 3. So if the 10 power 3 you go to this side, 10 power minus 3, here 10 power 5 is there, and the 10 power 4 is there. Therefore, we will cancel 3 by 4, we will get 7.5 kilometers, right? And see the next one, the height of the antenna required to transmit the modulated signal of frequency for 1 megahertz. The same type, but here megahertz. Mega means 10 power 6. Therefore, lambda by 4, which is equal to c divided by 4 nu. C is the speed of light, 3 into 10 power 8, and divide by 4 into 1 into 10 power 6. 10 power 6 nothing but mega. So therefore, you will get 75 meter. Okay. So comparing the first and second equations, antenna of height 75 meter while one of the 7.5 kilometers is not possible. So it is clearly, yes, manifest that modulated signal reduce the antenna height and are required for long distance transmissions. Okay. Next, propagation of electromagnetic waves. Yes, it is a new topic, propagation of electromagnetic waves. We know that what is electromagnetic waves, EM waves, right? So here propagation. So what is propagation? Propagation is nothing but, yes, just we are sending the signals. That is the process called as propagation. See the different ways of propagation of electromagnetic waves depending on the frequency, and the radio waves and the microwaves travel in space in different ways depending on their behavior of these waves. Okay, and at the atmosphere, yes, what are the propagation? The propagations are three types. One is ground wave propagation, another one is what, sky wave propagation, the other name is ionospheric propagation, right? The third one is space wave propagation. So these are the types of what, propagation. The propagation is nothing but the signal transfer from one place to another place, that is propagation. Here three types propagation. One is ground wave propagation, another one is sky wave propagation, another one is space wave propagation, right? Okay, shall we go to the ground wave propagation? Yes, before that, for all the types of what, propagation is in electromagnetic waves. See the first one, space wave communication, their power density attenuation, and third one is range of electromagnetic waves, and fourth one ground wave propagation, fifth one sky wave propagation, sixth one space wave propagation, seventh one TV transmission and height of a TV antenna, and the eighth one is satellite communication, and the ninth one is what, remote sensing satellites. This is the what, propagation. Okay, now see the first propagation. That propagation nothing but what, ground wave propagation. Which wave propagation? Ground wave propagation. See that. So this is the earth, yes, direction of waves signals near the surface of earth, that is tower to tower, yes, communication. Yes, that is what, ground wave propagation at frequency up to 2 megahertz. The most important method of propagation is by ground waves, which are vertically polarized. At the same time, they follow the curvature of the earth to propagate far beyond their horizon. Yes, relatively high power is required for this propagation, right? Ground wave propagation. At the same time, in the ground wave propagation, the radio waves travel along the surface of earth, and these waves are called ground waves, or which waves, surface waves, right? Okay, yes. In fact, these waves are not confined to surface of earth, but are guided along the earth's surface, and they are followed the curvature of the earth, right? And the same time, see the third one, the energy of the radio waves decreases as they traveled over the surface of the earth due to the conductivity and permittivity of a earth surface, right? The same time here, attenuation increases with the increase in frequency, but the wavelength will be decreases, right? So therefore the ground waves are limited to frequency of 1.5 megahertz, that is 1500 kilohertz. Their wavelength is 200 meter, right? Okay. Yes, the ground wave propagation has disadvantages. What is the disadvantages? It requires relatively high transmission powers. That is main disadvantages of this ground wave propagation. And that yes, second one is frequencies up to 2 megahertz only. Yes, above that it is not yes transmitted to the yes another transmitter, right? Okay. And require large antennas. Okay. And the next one is ground wave get attenuated. Yes, that is loss, decrease that what? Yes, frequencies. And attenuation increase that with the what frequencies. Yes, this is the disadvantages of what? Ground wave propagation, right? Next, propagation is skywave propagation. Which wave propagation? Skywave propagation, right? So this propagation, see this earth, on the earth surface receiver, and the one is what? Transmitter. When the transmitter transmit the signals to the space, and these waves are hit into what's ionosphere medium and reflected, yes, by this ionosphere medium, and finally reach the what? Receiver. So in this process, in this skywave propagation covers wide range. Which range? Wide range. Okay. See that dominant mode of propagation for EMFs in the frequency range of 2 megahertz to 30 megahertz, right? It covers long coverage. It obtained by reflection of wave at the ionospheric and the earth boundary. Yes, this method is used in high frequency band, that is international broadcasting. Yes, that is software radios, international, most kind of like BBC, right? Okay. And skywave propagation is caused, yes, primarily by reflection from the F layer. Which layer? F layer. That means the F layer contains of 90 to 25 miles in altitude. So see this transmit, this is ionosphere medium, and this is signal propagation, right? Okay. Yes, the skywave propagation is also known as skip ionospheric hop wave. The skywave propagation can include multiple hops between the earth and the ionosphere. The frequency range is already, I said, 2 to 30 megahertz, right? 2 to 30 megahertz. This is about what? Skywave propagation. And the last information for skywave propagation is, first one, the skywave propagation is also called ionospheric wave propagation. The electromagnetic waves is directed upwards at the same angle from the Earth's surface are called sky waves, right? The skywave propagation is useful in the frequency range of 2 to 30 megahertz and for long distance communication. Yes, and the last, the third one is ionospheric is the upper portion of the atmosphere between 50 kilometer and 350 kilometers above the Earth, which is ionized by absorbing large quantities of radiation energy from the sun. Okay, the last one is the major ionization is from alpha, beta, gamma radiation from the sun and cosmic rays and the meter. Okay, this is about what? Skywave propagation. The signals are transmitted to the ionosphere medium and reflected by the ionosphere medium and then finally received by the receiver. This type of communication is skywave propagation, right? In that skyway propagation there are two important thing is present. One is skip distance. The skip distance is the distance a radio wave travels, usually including a hop in the ionosphere. The skip distance is the distance on the Earth's surface between 2 points where the waves from a transmitter and refracted downwards by different layer of the ionospheric medium or ionosphere then fall. Yes, this is the skip distance. That is the distance between the point of the reception and the point of what? Transmission. Yes, this is the skip distance, shortest distance between the point of transmission and the point of reception. Okay, in the earth surface, that is skip distance. And but if you go to the next one is skip zone. Yes, in skip zone there is no electromagnetic waves present. That is very basic thing. Okay, a skip zone is also called as silent zone or zone of silence. Is the region where the radio transmission cannot be received and where the radio signals are cannot be received. That is what? Skip zone, right? And the zone is located between the region both closer and farther from the transmitter where the reception is possible. Okay, this is the skip zone. So skip distance and skip zone is very important thing in skywave propagation, right? Okay. Yes, then the last one is space wave propagation. Which wave propagation? Space wave propagation. Yes. What is space wave propagation? Yes. See this? These waves occurs within the lower 20 kilometers of the atmosphere because atmosphere contains of n numbers layer, no? Therefore, lower 20 kilometers from the atmosphere and are comprised of a direct and reflected waves, right? And the radio waves having high frequencies are basically called as space waves. Okay, which waves? Space waves. These waves have the ability to propagate through atmosphere from transmitter antenna to the what? Receiver antenna, right? And these waves can travel directly or can travel after reflecting from the earth's surface to the tropospheric surface of the sun. So it is also called as tropospherical propagation. Which propagation? Tropospherical propagation. Okay, and see that limitations. What are the limitations? See the limitations. As the form of electromagnetic radiation like light waves, radio waves are affected by the phenomenon for reflection, refraction, diffraction, absorption, polarization, and what? Scattering. And it has some limitations. See the first limitation. These waves are limited to the curvature of the sun. And the second one is these waves have line of sight propagation, means the propagation is along the line of what? Distance. The line of what? Distance, right? You see that last information. The EM wave that propagate from the transmitter to the receiver, yes, in the earth troposphere is called as what? Wave. Yes, you understand for this one? Yes, is the second point. Troposphere is the region of the atmosphere with 15 kilometers above the surface of earth. Okay, and see that the last one, the maximum line of sight distance between antenna, yes, between antenna of the height of the which one? Antenna. Yes, this is about what? Space wave propagation. The signals are transmitted to the space and the space receive the signals and send back to the, yes, which one? Viewers or users. Okay. Yes, so in your book I think 4 problem is given and this is the first problem. Okay, it's very simple problem, so please try to understand because the picture is not clear, I think. So therefore please understand. A transmitting antenna, the question is that transmitting antenna has a height of 40 meter and the height of the receiving antenna is 30 meter, right? And what is the maximum distance between them for line of sight communication? The radius of earth is 6.4 into 10 power 6 meter. Okay, for the radius of earth, so therefore we have to take distance. So d is what here? Distance. The distance of the is which one? Radius. Therefore root of 2 rh. H is what? Height. Therefore d is equal to d1 plus d2. What is d? D is equal to 2 into root rh. R is the radius and h is height. Okay, if you are taking the diameter d square, you will get what? 4rh. Which one? 4rh. That's why if you are taking d, you will get what? Root 2 rh1. So the same way for which one? d2, root 2 rh2. Okay, so root 2r is common, therefore root h1 plus root h2, and r is 6.4, that is radius of earth, into 10 power 6 meter is equal to what is the height? For height is 40 meter and receiving antenna height is what? 30 meter. So therefore 30, so we will get what? 16 into 10 power 2 and root 5. Therefore this side root 40 and root 30, root 40 will get 6.32 and which one? Root 30 5.48. Yes, you will multiple and all the values, you will get that answer 4200 and yes, sorry, 42,217 meter, that is equal to 42.217 kilometer. Yes, this is very simple example problem. Yes, followed by the which one? Propagation topic. Okay students, today's class is over. Yes, thank you. We'll see you on next class. Okay students, thank you.